So the empirical rule is just a stronger version of Chebyshev's rule that we can use when our data or variable is normally distributed. Um, this might be known from looking at the data, right? So if you make a histogram, you can see your data looks like it's normally distributed. You could probably go as far as to use sort of the empirical rule, but we use this more often in intro stats in situations where we know data to be normally distributed. So someone has told you the data is normally distributed, and it's a great stepping stone for where we eventually go, which is to find exact percentages and probabilities from the normal distribution. So over time, I've become less enamored with the empirical rule because it only allows you to do so much. And so let's just go ahead and talk about this. So I went ahead and found the CDC health data in terms of like growth charts for boys and girls. So my kiddo is about to be 5, so I grabbed this section where we have boys 5 to 5.5 years old. This is when we get that growth chart at the hospital, right? Every time you go, there's like a new dot. And so the mean and standard deviation for boys in that age range is 110.94 centimeters and 4.92 centimeters, respectively. So what this would mean if I wanted to use the empirical rule to talk about a height for a boy in this age group would be that I could take this uh, normal curve that's drawn right here. I'm going to go ahead and just erase essentially these numbers here at the bottom, and I'm going to replace them with my mean, which we said for this group is 110.94 centimeters. And then as I move to the right, I'm just going to add standard deviation. So I take that 110.94 and I'm going to add 4.92 to that. So this next value is 115.86 centimeters. Not liking how much space that's taking up. Add another 4.92. I'm now at 120.78. And then add our last 4.92, moving in that direction, and we get 125.7. In the other direction, we're just going to subtract standard deviation. So essentially, we're making something a little more detailed than Chebyshev's rule gave us before, that we could have made this for Chebyshev's rule. We just wouldn't have had like a cute curve, right? We would have just had within one standard deviation, 50%, within two, at least 75, and then within three, at least 89%. But it would have the same values at the bottom. I got distracted. Minus 4.92, we get 106.02. Subtract another one, 101.1, and a last 4.92 takes me to a 96.18. Yes. All right. Now, so what this tells us is, right, I could say the same things we said before with Chebyshev's rule, but with like larger percentages, is that 95%, right, 95% of boys in this age range are going to be between 101 centimeters tall and 120.78 centimeters tall. This is what the empirical rule tells us. Now, why the empirical rule is not as strong as what we're going to be able to do later is we all know when you see this fact, in fact, let me go grab the rest of this chart. Come on. When we get this thing, it doesn't just tell us only about these particular 7 values that we have here at the bottom. We have a lot more. We could talk about any of these other values, right? So we get out when we go to like the doctor, the actual percent or percentage or percentile for our kid, regardless, right? And so here we can see this, right? There's more than just 7 values here at the top. Yes, there are some of them that we've seen here, but not all of them. And we could even see, like, let's see, that 120.78 is right around that 97th, which this is 97.5%. They don't have these exact values because these values are a little silly, but they have more. And that's because when we actually have the normal distribution, we can talk a heck of a lot more about that. So we'll have an example, I think, following this of how you might see the empirical rule used in an intro stats class. Um, it's, I guess, good practice at sort of dividing up this curve that is 100% in ways that we might find useful as we move forward to the normal distribution. But it's a little silly because we're going to get a stronger way to deal with this soon.